All right, guys, we're going to go over the answers to the review. All right, for your quiz that is tomorrow. The quiz will have the same types of questions, obviously much, much shorter. All right, just like a couple of each thing. Obviously, some of these are much, much faster and quicker than some of them. Okay. All right. So when you're evaluating these logs, all right, remember it's whatever the base is to what power equals that number. Okay. Since we have a 1 over this, it's going to be a negative exponent. All right. 5 to what power gives you 125? That's 3. But since it's 1 over 125, the answer is going to be negative 3. All right. When you have a natural log, remember the base is e. So it's e to what power gives you the fifth root of e? Well, fifth root of e is e to the 1/5. So our answer is 1/5. All right, whenever you have a log up in the exponent like this, all right, whenever the log is in the exponent like this, and the base of the log is the same as the base right here, which is e, which we have here, this can be simplified, all of this, to whatever is after the log, which in this case is the square root of 7x plus 3. And that is your answer. All right. So right here, we have the same exact type of example. We'll worry about this x cubed in a second. All right. We have a log up in the exponent with the same base as we have here. So all of this, you just take the x to the 68th. Just becomes x to the 68th. But we already have x cubed there. So what's x cubed times x to the 68th? X to the 71st. All right. All right, natural log of 1, e to what power equals 1? Well, the way to get 1 is always the 0 power. This is just something the natural log of 1 is always 0. All right, here we go. Another example in F of what we had here in C and D. E natural log of x, they have the same base, so this just becomes x, but I already have an x up front. X times x is x squared. All right. Now, this one, 2 to what power gives me 256. All right, so do that a little bit. 2 to the 5th is 32. 2 to the 6th is 64. 2 to the 7th is 128. So 2 to the 8th is 256. Right, 2 to the 8th is 256. Right. This one here should not have been in this section. All right, this should have been down below. The only thing here you can do is just expand. So 3 natural log of x plus 1/4 natural log of 2x minus 1. Right? This should not have been in this section. On the quiz, the first part of your quiz will have ones like this. This will not be in there. Okay? Those would be in the, right, it should be in question number 2. Right? All right, so question 2, we have use the laws of logs to re-raise the sum difference or multiple of logs. All right, so we're just going to expand this. All right, remember, everything up top gets a positive, everything at the bottom gets a negative. Any exponent goes out in front. If it's a root, remember, it's just this case would be 1/8. All right, so we got 1, 2, 3 things. So I have 3 logs. So it's 3 natural log x. The 3 comes from the exponent. Plus, because it's on top of the fraction. 6 because it's an exponent, then we put the natural log, and then whatever is being raised to that power, which is x plus 5. We go on the bottom here, it's a minus 1/8 because the 8th root, that's what the power is, natural log of 4x minus 2. All right. For this one, we have 2 things. So it's going to be 2 natural logs. Now notice the cube root is to both of these. So it's like both of these are being raised to the 1/3. Okay. Now, if I go 2 to the 1/3, that's really 2/3. Okay. So, or think about it, if I have 1/3 on the outside, then I move it 2, 1/3 times 2 is 2/3. So the second one here is going to be a 2/3, not just a 1/3. Okay. So this is not being raised to anything else, so it's just going to be the 1/3. So 1/3 natural log of 4x minus 1 minus 2/3, because we have the 2 here. It's also being raised to the third. Power to a power, we multiply. Natural log of x plus 3. All right, so definitely 1 or 2 of those, but these should go by pretty fast. All right, then we have a condensing one. All right, as soon as you see these negatives, now we're going to have some sort of fraction. So just make a big natural log and put a fraction bar. Anything with a positive goes on top. Anything with a negative goes on the bottom. All right, so it's x to the 7th. How do I know it's the 7th? Because anything out in front, that's an exponent. 1/5 means we're going to have the 5th root. And I know I put it up top because it's a positive. 6x minus 1. All right, now I have a negative, which means I go to the bottom. X minus 2 to the 5th. Minus, I stay on the bottom. So 1/8 means the 8th root. That is an 8, promise. Of 3x minus 4. All right. All right, graphing. All right, will be a couple graphs in here. Remember, there's basically 4 things that can happen. Negative out in front is a horizontal flip, which means I flip it over the x-axis. This moves it up 2. If it was negative, it moved it down 2. This you set equal to 0 and moves it to the right 4 because it's a positive 4. This would be a, did I say horizontal flip? This is a vertical flip. I said the right thing over the x-axis, but I wrote the wrong thing. This is a vertical flip with a negative out in front. All right. Now, if there was a negative in front of the x, that would be a horizontal flip over the y-axis. All right. So remember, our basic shape is an asymptote there and 1, 0. That's all you have to do is 1 point. That's all I want. Make it really easy for you. So since it doesn't move left or right, you still have a vertical asymptote. All right. Normally I'm at 1, 0. Flipping it over that axis doesn't do anything, but instead of going like this, I go like that. All right. For this one, I moved it up 2, but that does not affect my vertical asymptote. All right. I would normally at 1, 0, but now I move it up 2. So now I'm just there. This one, we moved it to the right 4, which means my vertical asymptote is now at 4. I was at 1, 0. I flip it vertically, nothing happens, but my point is now here at 5, 0, and it gets flipped, so it looks like that. Right? I think the domain is under here. I just never, yeah. So the domain for each of these is whatever the, if it's on the right side, the vertical asymptote, in this case is 0 to infinity. If it was on the left side, it'd be negative infinity to whatever the vertical asymptote was. So this one is 4 to infinity. All right. So it'll be a couple basic ones like that. All right. So now we get into the meat of what you need to make sure you know how to do, which is the next 2 sections, which is derivatives and integrals. Okay. Now remember that for the derivative of a natural log, it is du over u, which means you take the derivative of the inside, whatever comes after natural log, over the inside, whatever comes after the natural log. So in this case, your x to the 6 is your u, which whatever comes after natural log. So it's the derivative of that, which is 6x to the 5th, over whatever that u is. In this case, whatever comes on the inside, derivative of the inside over the inside. That simplifies to 6 over x. All right. Here, same thing. You're just figuring out what's the derivative of cosecant 3x. Now remember, you're allowed to use your formula sheet. You can use your formula sheet. So the derivative of cosecant is negative cosecant cotangent. And then I got to take the times the derivative of the inside, which is 3, over the inside. Well, cancel, cancel. You're left with negative 3 cotangent 3x. There's your answer. All right, something like this. Well, this is chain rule. All right, so we have this whole thing is being raised to the 6th power. So you take the derivative of the outside, which means you do the power rule, keep the inside the same. The 6 becomes a 5. But now I got to take the derivative natural log of 5x. Remember, the natural log of any number x is always going to be 1 over x. The reason is because the derivative of 5x is 5, over the inside is 5x. These are always going to cancel. It's going to leave you with 1 over x. Right? So your answer is 6 natural log 5x to the 5th power all over x. All right. All right. So for D, all right, we have a reverse of what we had in B. All right. So that you would have the natural log with the trig on the inside. Now you have a trig with the natural log on the inside. All right. You definitely expect to see something like this on the quiz. So cosine is negative sine. Keep the inside the same. And then take the derivative of the inside, but the natural log of 5x is just 1 over x. So it's negative sine natural log of 5x all over x. If you left it like this, I'm not going to probably take off. All right, but this looks better. All right, here, natural log of x over x squared. It's not the natural log of x. This is not all on the inside. This is 2 separate things. This is the quotient rule, all right, which is the bottom times the derivative of the top, which is 1 over x, minus the top times the derivative of the bottom, which is 2x, all over the bottom squared. Just to save something here, I don't want this complex fraction. Oh, actually, I don't have a complex fraction. This is great because this cancels, and that just becomes x. So my answer is x minus 2x ln x all over x to the 4th. And there's your answer. Now, if it wouldn't cancel here, what you would do is just multiply everything by x. Would have got rid of that, but no need. All right. F. See how that everything in here is in the inside of this natural log? So what you're going to want to do is expand this first. All right. So this is 4 ln x, right? Plus 1/2 ln of 5x plus 3. All right. So you expand first. Now just take the derivative of these two terms, which is 4 times 1 over x, because the derivative natural log of x is 1 over x, plus 1/2. And then we do du over u. The derivative of 5x plus 3 is 5 over 5x plus 3. And my final answer is 4 over x plus 5 over 2 times 5x plus 3. You don't need to actually multiply it out. Just do it just like that. There is my answer. All right. Now, so, I'm not saying there's going to be 6 of them. I'll probably cut it down just a little bit, but these are the types of ones you want to make sure you do. All right. If you can do these 6, you're going to be good. Now, this G, all right, should be in 6 because it's going to be use logarithmic differentiation to find the derivative. That's how you're going to do that one. All right. So there will be one logarithmic differentiation, but it will say in the direction to use logarithmic differentiation. All right. Otherwise, this, you might not realize right away that's what you have to do. All right. So we have this real complicated looking thing that what we're going to do is take the natural log of both sides. All right. So we're going to expand it. All right. A little what we did here, but just a lot bigger because we have so didn't have a natural log to start with. So natural log of y equals 4 natural log of x plus 2 plus, remember on top, so I still use a plus, 5 natural log of 2x minus 1, just expanding this, and we're going to take the derivative of each one, minus 3 natural log of x minus 1/2 natural log of 4x plus 3. All right, now to be honest with you, this one's a long one, and I probably wouldn't give you this one on the quiz. This one's a little shorter. There's only 3 things to do, a little bit more indicative. All right, but the steps are the same. All right, so when you have this logarithmic differentiation with natural log of y, the derivative of y is 1 over y. Sorry, derivative of natural log of y is 1 over y. And then we get this dy over dx, right? Let me just change color so you know I'm doing the derivative here. So 4 times the derivative of this is 1 over x plus 2 plus 5 times the derivative of 2x minus 1 is 2 over 2x minus 1. See, these aren't hard derivatives once you do this. 3 derivative at natural log of x is 1 over x minus 1/2 times the derivative of 4x plus natural log of 4x plus 3 is d over u. So it's 4 over 4x plus 3. All right, so just to simplify all that, that's going to be 4 over x plus 2 plus, not 5, it's going to be 10, because 5 times 2 is 10. 10 over 2x minus 1 minus 3 over x minus this 2 is going to cancel that 4, make that a 2. 2 over 4x plus 3. Okay. So the only thing we have to do, we are solving for dy dx. So this is the kind where you solve for y, that cancels that, and we're going to solve all of this, multiply all of this by y. You do not need to rewrite it. Literally just do this. This is what y is. Y is all of that, and draw an arrow. Okay. If you want to rewrite it all in, feel free, but you do not have to. All right, and that's your answer. All of this is your answer here in the pink. All right, so 6 is the exact same thing, but notice it says the directions use logarithmic differentiation to find the derivative. All right, so it's exactly what it is here. We're going to take the natural log of both sides. All right, so we get the natural log of y equals, and now we expand it, 2 natural log x plus 1/2 natural log of x plus 1 minus 6 natural log of 9x plus 2. All right. All right, so now we take the derivative of everything. All right, so this is always 1 over y dy dx, and that's what we're eventually going to solve for, equals 2 times 1 over x, because the derivative of natural log of x is 1 over x, plus 1/2. Whatever's in front of the natural log just stays there, multiplied by whatever, do the derivative of all of this, which is derivative of the inside. The derivative of x plus 1 is 1 over the inside, which is x plus 1, minus 6 times 9 over 9x plus 2, which equals, I'm just going to simplify all of this, 2 over x, it's combining these, plus 1/2, 1 over, yeah, because 1 times 1, 2 times x plus 1, minus 6 times 9 is 54 over 9x plus 2. All right. And then all of this, I'm going to multiply by y. And what is y? Y is this right here. Draw the arrow, and there is your answer. All right, so that is logarithmic differentiation. There will be one of those on there. All right. All right, in the last section, number 7, these are all your derivatives. I'm sorry, not derivatives, integrals. All right, and there is a lot on here. There will obviously not be this many on the quiz, not nearly this many at all. All right, but these are the types that you want to make sure that you know how to do. Okay. If it's one where you don't have to use u, I think you guys are pretty good at noticing you don't have to use u. But if you do have to use u, anytime you have a fraction now, you can use u as the denominator. You can get du over u. All right. You might have trig where you're making u either the denominator, the bigger trig if it's raised to different powers, or whatever. U comes right after the trig. Or if you have a power raised, so quantity raised to a power, the u might be on the inside of that or underneath a radical. All right, those are the different ways we have to do it. All right, so for this first one, the only thing I can think of is we have a fraction. We make the denominator our u. All right, so u is 2x minus 1. We do our du, which is 2 dx. We need all of our du here, so I added 2, which means I put a 1/2 on the outside because I added the 2 in. Integral of, well, 2 dx is du over u. All right, and if you forget what du over u is, you look on your formula sheet. All right, remember you can look on your formula sheet and you look and it says like integral, oh, du over u is the natural log of u plus c. All right, so use the formula sheet. Okay, so I get the, so I just write 1/2 natural log of the absolute value of u, which is 2x minus 1, plus c, and I'm done. That's all you have to do. Okay. All right, here, make the u once again, make it the denominator, x cubed plus 1. And if something doesn't work, you just try something else. All right, 3x squared dx. All right, I add in the 3. So there, all of that is my du. So I added a 3, so I make it 1/3. Integral, what do I have there? I have du over u, which is 1/3 natural log of whatever u is. In this case, it's x cubed plus 1 plus c. Okay. So for this trig here, okay, I have 2 trig functions, different powers. All right. So my options are I either can make it the entire bottom or just tangent 3x. All right. Try both. I would personally probably think, well, if I do the bottom one with that power, to take the derivative of that, I'm going to use chain rule. And I don't really feel like doing that. So let me mean like really complicated. Double chain I would have to use. I don't want to have to use that. So let's just take tangent 3x. Going off the premise, we have 2 different trig functions, different powers. We take the one with the highest exponent. So then the derivative of tangent is secant squared 3x times 3 dx. So I put a 3 up here. All right. So there is going to be my du, right? So you might be thinking, oh, wait, this is going to be du over u, but it's not because what's on the bottom. So it's 1/3 integral du over u to the 5th. So this is not du over u. So this is 1/3 u to the negative 5th integral. Forgot the integral sign. All right, du. So when you integrate that, you get 1/3 u to the negative 4th over negative 4 plus c. So your answer is negative 1/12 tangent 3x to the 4th power, all in the bottom, plus c. Okay, so it's not always going to be du over u. Okay, all right. Nice, easy trig one. You just have one trig function. You make u whatever comes after it. U equals 5x. The derivative is 5 dx. I put a 5 here. I put a 1/5 on the outside. It's the integral of secant u du. Probably shouldn't. That's tough to memorize. I don't memorize it, so I'm going to go look. Oh, integral of secant u du is a natural log of secant u plus tangent u plus c. So you just copy it down. That's all you're doing. 1/5, leave the 1/5 the outside. Natural log, absolute value of secant u, which is just secant 5x, plus tangent u, which is tangent 5x, plus c. All right, done. All right. Another one-time trig function. One trig function, make u whatever comes after it. U equals x squared. If this doesn't work, there's nothing else you could do. 2x dx. I add a 2 there. All right, I added 2, which gives me 1/2. The 2x and the dx is my du. Integral of cotangent u du. All right, you look here, cotangent u du is the natural log of sine u plus c. So it's 1/2 natural log of sine u, which is sine x squared, plus c. Done. All right, use that formula sheet to help you out. All right, so this trig one. All right, you have cosine 5x. You have 2. You see this other thing here? This is going to cause maybe an issue. My first guess would be if you make it 5x, you're going to see 5dx is not going to work right away because they have the same power. All right, so since you have a fraction, then try the denominator. Okay, the derivative of 3 is 0. The derivative of negative sine 5x is negative cosine 5x. This is negative because that's negative, okay, because the derivative of sine is cosine. But since it's negative sine, it's going to be negative cosine. Negative cosine 5x times 5 dx. All right, I need to add a 5 up there, which means we have a 1/5, and it's actually going to be a negative, right? So I need a negative 1/5 there. Integral of all of this is du over u, right? Because 3 minus 5x's are u. So I get a negative 1/5 natural log of, what's the u? 3 minus sine 5x plus c. And there's your answer. All right, this one could be a little tricky of trying to figure out what you can make u is. And this is actually going to be the natural log of x. All right. We're going to make u equals natural log of x. The derivative of that, the reason is because what's the derivative of natural log of x? It's 1 over x dx. All right. So there's your 1 over x dx. So I don't need to add anything. This just becomes, I already have all of my du right there over natural log of x my u. So the answer is just the natural log of the natural log of x plus c. All right. There you go. All right. For h, all right, we have one trig function. Let's pick whatever comes after it. It's also what's in the bottom. So it's like it has to be that, right? So you get the square root of x, which is equal to x to the 1/2. All right. We take the derivative of that. It's 1/2 x to the negative 1/2, which is just 1 over 2 root x dx. All right. So I need all of this. I have the square root of x. I don't know where they're missing a dx. That dx should already be there. Put a 2 on the bottom. I need the 1/2, which means I actually have a 2 on the outside. All right. All of this is my du. So I'm just left with tangent u du. All right. So we look at my integrals here. Tangent u du is negative natural log of cosine u plus c. So it's negative 2 natural log, and I have already forgot what it is. It's cosine, sorry. Cosine of the square root of x, because that was u, plus c. And there's the answer. All right, use your formula sheet. All right, use that formula sheet. All right. Now, two trig functions, sine 5x, cosine 5x. You take the one with the higher exponent. So that's going to be sine. So sine 5x. I take the derivative of that. The derivative of sine is cosine. Keep the inside the same times the derivative of the inside, which is 5. I just need to add a 5, and there's my du. All right, so I get 1/5 integral sine 5x, well, that's u to the 4th du So this is like when we first started off with, the beginning of doing integrals. This is u to the fifth over 5 plus c. So the answer is sine to the fifth power of 5x over 25 plus c. All right. All right. So not sure when I just paused that. So this is what you get for your final answer. All right. All right. All right. So I hope that you guys caught all of this. So this one, if I just noticed it wasn't recording, I just don't know when I hit pause button. So I hope you saw the explanations to almost all these. It says it's 30 minutes, so that should get me through. I'll go back and look, and if you have any questions, you know, here I'll just scroll through these last few that you can always just pause the screen on and look, and you can probably figure out where I got everything from. We've done enough of these examples by now. It's all basically about picking what the u is and then going from there. So hopefully you saw that the reason I couldn't do this is because you can't add a variable. Like I said, you might have heard all the explanations. Sorry if you didn't. I don't know when it cut off. All right. I'm just talking to air, hopefully not, hopefully you got it all right, but just like I said, it's showing you here, so you can always pause and look and see where I picked all my u's and du's and got all that stuff from, right? If you have any questions, please reach out, and I will answer them to the best of my ability. Okay. I'm afraid to stop there. Okay. So quiz tomorrow, and I'll post on exactly what types of how many questions. It's gonna be much shorter. It's gonna be these types of questions, just much shorter. All right. Hope all is well. Talk to you guys later.